Hi, good afternoon, everybody. It's great to be back here after 3 years. I really miss, the Telematics 2019, where we had a lot of fun in Minsk. But for those that know me, I've been an implementation partner for the past 4 years, but this year I'm coming back as a technology provider, and I hope to introduce our new solutions and products that will help you to enhance your existing solution, upsell your solutions, and open up new markets, for growing your business. So, AetherIoT, we are a Singapore-based company, and we're a solution provider that provides real-time location tracking and sensor data, RTLSS for short. We aggregate various hardware that spans across multiple radio technology. So we don't just work with GPS trackers with cellular technology, but we span across various other technologies, including wireless mesh, LoRaWAN, BLE, ultra-wideband, because no one single technology can address all the needs as you provide tracking end-to-end within the facility, outside the facility, and in transit, and even across the world. So we provide IoT connectivity across various kinds of radio technology, and we aggregate all this into a middleware platform, and normalize the data, which we then integrate to FlashBee, which you can then stream over to Wialon. So someone tells me, what are you doing? Are you trying to do a FlashBee? I said, yeah, FlashBee does one layer, which is very great, and it's a great product for GPS connectivity. And we take care of other connectivity in the low power, wireless connectivity space, which includes, LoRaWAN and ultra-wideband and such. So, for those that remember, in 2019, I actually did a presentation, and you can still find it on YouTube actually. So I'm a YouTube star. Thanks to Gurtam. I was presenting a solution that we were developing for a supermarket chain customer in Singapore, where they were trying to track their cargo that is on pallets and roll cages in the back of the truck. And what we then proposed to help them track and automate the process from their distribution centers, to their chain of supermarkets, and then collecting their empty roll cages and pallets back to the DC, was using BLE technology, a BLE asset tag with temperature humidity sensors, because they're dealing with also cold chain and perishables. And we put a BLE lock at the back of the truck, and we were trying to then use a BLE-enabled GPS tracker to read the tags and, to provide, the cargo visibility and environment status on the Wialon platform. Well, to share with you some of the challenges and limitations that we faced during that implementation, which we eventually managed to overcome to some level of success. First of all, is the distance. What you find is that on most GPS trackers that has an onboard BLE, it does has a limitation on the distance. It cannot reliably read all the way to the back of the truck, which could be up to around 40 foot or 50 foot long. I mean, if you include the truck head and everything else, your reader is up there in the truck head, and you have pallets that could be stacked all the way to the back. You may think that BLE could work, 40, 50 meters. They publish, well, try it for yourself. You're dealing with a metal container, and next, you're dealing with dynamic content within the truck. Imagine what happens you load a pallet of Coca-Cola cartons. It's metal container with liquid inside. Your RF does not like that. And so your range and all that is limited. The other thing is that the number of tags that you can in theory scan and all that, you're not talking about a dedicated BLE reader that is constantly on. You're talking about onboard BLE that is through a time interval of scan intervals. What we found is that with each scan intervals, you pick up partial the text, and sometimes certain text will never get picked up at all. And this is because the tags are constantly beaconing and creating a lot of noise and interference. So, how do we solve the issue that make it work? Well, we then installed a external BLE reader into the container at the back, in the middle. And we have to wire it to the GPS tracker in the front. And it works. We extended the range. We managed to give a solution to the customer. However, it's a real pain to install this BLE reader through the wires. We have to drill a hole through the aircon duct, and then we face a lot of issues with the wiring and making sure they don't get cut by the roll cages that's coming on and off the truck. And it's not scalable because our customers happens to have a refrigerated van that's not detachable from the head. But if you look at shipping containers, the shipping containers sits on flatbed that can be detached. How are you going to install anything permanent? And a lot of times, they don't even own the trucks. They outsource this to third-party logistics provider transporters. And so these transporters won't allow them to do anything on their own trucks that they don't own. How do we later manage to solve this issue? We managed to find a wireless mesh technology that came from Wirepass from Finland. It was they call it a very, very good IoT. It uses decentralized nodes, battery-operated nodes, that is self-discovery to create a mesh network. So first, we solved the issue of installation. There's absolutely no wiring. It was so simple to plug and play, and it just simply create a mesh network. There's no limitation of distance because the tag that's right at the back of the truck simply hops to the front and sending its data through the network. And we're even testing on a train. So it can go like 10 hops, 20 hops. There's, in theory, no limitation in the distance. Third, there's no limitation in the number of tags that it can be supported. In fact, it can support up to 1,000 tags per meter cube. Try and do that with regular BLE. The difference is that the regular BLE constantly beacon. These do not. They have an adaptive transmit and receive time synchronized. They use time synchronized transmit and receive between nodes, which then guarantee the delivery of the data from one node through the intermediate nodes to the gateway. So, in the end, we establish a highly reliable mesh network that is scalable and self-healing. Now, the good thing is we have integrated with 2 of the top 3 manufacturers of Gurtam, Telconica and Quacklink. We tested this. It was relatively easy to set up within minutes. And all the data is flowing into the FlashSpeed platform, which you can then stream into Wialon, right? Now, what does wireless mesh give us? While we created this for the in-transit visibility, the wireless mesh technology, we really target at indoor real-time location tracking and sensor data. And if you look at the market research, it's something that is huge. There's a market potential of 20 billion that's growing year on year. In fact, RTLS is not new. I've been working with RTLS systems since the early 2000s, where I was using WareNet, I was using RF code, I was using AeroScout. These are proprietary technology that were very expensive, that only the military and high-end industry is able to achieve. However, the last 15 years, a lot of things have changed. BLE has become widely adopted and has brought down the cost down to mere dollars. Ultra-wideband, which is another technology that we can look out for, is being adopted on the mobile phones of Apple and Samsung. And that is driving also the cost of the module down. So what we found is that close to 2019, 2020, the price point of all this RTLS system has reached a level where it can be mass adopted. The pandemic just simply accelerated a lot of the adoption, because during the pandemic, everyone was looking at, people tracking occupancy sensors, air quality sensors. In the supply chain, we had a lot of issues, and I have a lot of interaction with, supply chain logistics, warehouse owners. They're trying to optimize their warehouse operations by locating, where their pallets are located within the warehouse, within the shop floor, factory outlet. So, wireless mesh is a technology that is very easy to set up, entirely battery operated. Each of them is an independent node that knows how to talk to its neighbor, uses an adaptive transmit and receive to send the data through short hops. With that, once we can create a network of the wireless mesh, we're able to achieve an accuracy up to around 3 to 5 meters. It depends on the density of where your anchors are being placed. The closer they are being placed, the more accurate it is. Okay? It's just like having satellites in your room. It uses the technology to try and do triangulation. We can, with the wireless mesh network in place, now we can add a lot of sensor data, because it's a two-way communication. I can send, sensor data from temperature, humidity, air quality, power meters, water flow meters. I can also send command down to e-paper relays or actuators and all that. And it gives and opens up a whole new business opportunity adjacent to the fleet management market, extending into the warehouse building facility at source and destination. So while wireless mesh, we find that it's great, but as I mentioned before, there's no one single technology that meets everything. So in some cases, I need sub-meter accuracy, and that's where ultra-wideband comes in. Ultra-wideband works totally different from all narrowband technology of, sub-gigahertz or narrowband, BLE. It's using time of flight, so it's able to achieve very high level of accuracy sub-meter, and it's also something that is, it works well in metal environment because it's not susceptible to interference. Now, in other places where we find that, it's sitting somewhere between the in-transit space where we have to use cellular and indoor space, outside the shipyard or things like that, we use LoRa, because LoRa has a range of around 1 to 2 kilometers, and if your assets doesn't move out of this area, why spend money, on SIM cards that you need to pay for? So we combine a hybrid system, combining the best of breed of various IoT connectivity for your solution. On our product roadmap, we are developing a couple of things. We just started 6 months ago, but we're combining GPS with LoRa outdoors that can then seamlessly move indoors with the mesh technology. We are coming up with a worker batch for oil and gas in Brazil. We are also integrating with various kinds of sensors for occupancy, water, power meter for smart building scenarios. So, what's our key takeaway? Wireless mesh enhance your fleet management, and solve the issues that BLE. I'm not saying BLE doesn't work. BLE works for fixed sensors like your fuel sensors and your tire pressure and all that. But we're dealing with cargo and dynamic, BLE has that limitation which wire mesh will solve. And, it opens up a whole new market in indoor space, which is the next big thing that a lot of people are talking about, indoor digitalization. And when we combine this with other technologies of LoRa and ultra-wideband, it gives you a whole spectrum of IoT connectivity. Now, before I finish my presentation, I would also like to introduce my hardware partner Unfortunately, they can't be here. They're under travel restriction. They can't fly out of the country. We work very closely with Moko Smart. And Moko Smart is a IoT device manufacturer. For us, it doesn't just make sense to manufacture devices because a BLE tech, they can sell it to me for as little as $6. There's no way I can manufacture that kind of price, outside of the Chinese factory, right? And they have a full range of products from BLE beacons, LoRaWAN devices, LoRaWAN and BLE gateways, and also module levels. So do visit their website or take a look at our booth. They have been a very good partner. Despite the shortage of Nordic chipset, we will continue able to produce because they really have the economy, the skills to secure all these kind of supplies when everyone else is having shortage. All right, so thank you very much. I have a booth outside if you like to take a look or feel free to contact me. See you around. Thank you.